Every dairy farm on the planet runs on the same basic animal. Cows, goats in some places, sheep in others, yaks across Central Asia, camels across the Middle East and North Africa, water buffalo across South and Southeast Asia. Every single one of them a grazing animal. Every single one of them eating plants. Now try to remember the last time you saw lion milk on a supermarket shelf, or wolf milk, or tiger milk, or shark, obviously, but try to picture it anyway. Humans have figured out how to milk nearly every large herbivore on Earth, across every continent and every era of history. But predators? We have essentially never done it. Not at scale, not as a product, not as anything resembling a habit. Across isolated cultures with no shared contact, no shared language, and no shared knowledge of each other's practices, every dairy tradition in human history independently arrived at the exact same animals. All of them grazers, none of them hunters. And if you actually stop and think about that, it is genuinely strange. A lioness produces milk, so does a cow. Both are mammals. Both are nursing their young with a fluid produced by the same basic biological mechanism. So why does one get turned into cheese, butter, yogurt, and an entire global industry, while the other has never once appeared in a glass in any civilization anywhere on record? The answer is not one single reason. It is biology, chemistry, and logistics, all stacking on top of each other, all arriving at the exact same conclusion. Let's start with the math, because the math nearly closes this argument on its own, before anything else even gets a chance. The same 10% rule that governs predator meat governs predator milk. At every step up a food chain, roughly 90% of energy disappears, burned as body heat, spent on movement, lost in the mechanics of simply staying alive. A grazing cow converts the energy in grass directly into the calories that become her milk. A lion converts the energy in prey animals that already burned through their own grass. She is producing milk from the third or fourth tier of an energy pyramid, and the cost of that milk is staggering before she even begins. To get a single gallon of milk from a lioness, you would first need to raise and feed the prey animals she would need to eat to produce that milk. And those prey animals would need their own acres of grazing land, their own water, their own years of growth. The energy math collapses before you can sketch it. No human civilization has ever had the surplus to run that calculation in the other direction. Grass to cow to milk is an efficient machine. Grass to prey animal to lion to milk is an energy disaster that has never been worth attempting. But cost is not even the biggest problem. There is something building up inside a predator's body that makes her milk actively dangerous in ways that have nothing to do with economics. It is called biomagnification, and it runs quietly through every predator on the planet, without exception. Toxins move up food chains, and they do not weaken as they go. They concentrate. A fish absorbs a small trace of mercury from the water around it. The predator fish that eats 100 of those fish absorbs 100 times that trace. The apex predator that eats 100 of those predator fish absorbs it all again. By the time you reach an animal at the very top of a food chain, you are looking at a creature that has spent its entire life accumulating everyone else's toxins in its tissue. And those toxins do not stay in the tissue alone. They concentrate most heavily in fat. And milk, by its very nature, is rich in fat. A nursing predator at the top of the food chain would be producing milk with a toxin concentration that reflects every level of the food chain beneath her. Scientists who have studied the milk of marine mammals, orca and polar bear especially, have found chemical contamination levels that would be considered deeply unsafe for human consumption by any regulatory standard on Earth. A 2008 study examining organochlorine compounds in polar bear milk found concentrations of industrial chemicals and pesticides that were among the highest ever recorded in any mammal's milk anywhere on the planet. The polar bear sits at the absolute apex of the Arctic food chain, and her milk reflects every layer of contamination below her, concentrated and delivered in the most bioavailable form possible to a nursing cub. The same biomagnification that makes predator meat dangerous makes predator milk orders of magnitude more concentrated, with exactly the same problems and no way to filter them out. And then there is the animal itself, before you ever think about what comes out of it. A cow stands in a field. She has been selectively bred across 10,000 years of human partnership to be calm, docile, and tolerant of handling. She produces far more milk than her calf could ever need because we have spent millennia engineering exactly that outcome. The earliest evidence of dairy farming goes back roughly 10,000 years to the Fertile Crescent, where humans began selectively breeding cattle for traits that made milking possible: lower aggression, higher milk yield, tolerance of human proximity. That process worked because the raw material, the aurochs ancestor of the modern cow, was already an animal that could theoretically be approached and managed. A lioness is none of those things. She is an apex predator whose entire biology is built around hunting, territorial defense, and protecting her cubs from everything that moves, including you. Attempting to milk a lioness is not an agricultural challenge. It is a guaranteed mauling with a dairy-adjacent motivation. The practicality problem is not a small logistical hurdle. It is a fundamental incompatibility between what predators are and what the milking process requires. The domestication of dairy animals took thousands of years of careful selective breeding applied to animals that were at least theoretically manageable. No predator on Earth qualifies. Even if you somehow solved the toxin problem and the energy problem, the animal itself remains an efficient killing machine that has no evolutionary incentive to cooperate and every biological instinct to attack. There is also what the milk would actually taste like, and the science here is not encouraging. Predator milk has an unusually high fat and protein content relative to herbivore milk, which sounds appealing until you understand where those compounds have been. The fatty acids in predator milk carry the flavor signatures of the meat those animals consumed. Researchers who have analyzed the milk of carnivorous marine mammals describe it as intensely fishy, extremely bitter, and almost impossible to consume in any palatable quantity. The biochemistry of predator milk reflects its source in the same way that what a cow eats shows up in her milk. Grass-fed dairy tastes different from grain-fed for exactly this reason. A predator fed on raw animal flesh produces milk that tastes precisely like what you would expect from that diet. The lactose content of predator milk is also dramatically lower than in herbivore milk. Carnivores have less evolutionary need for the sugars that make herbivore milk digestible and palatable to other species. What remains is a high-fat, low-sugar, intensely flavored fluid that the human palate has no history of finding remotely acceptable. And it turns out that almost nobody, across all of human history, has found it appealing enough to justify solving any of the other problems. Now, the pattern is not completely without exception. History surfaces a few, and they confirm the rule more than they challenge it. Wolf milk has been consumed in tiny quantities in isolated contexts, almost always in ceremonies rather than as food, and almost always with significant preparation. There are records from Roman mythology of Romulus and Remus being nursed by a she-wolf, which tells you something about how this tradition was treated, not as an agricultural fact, but as a founding myth. When predator milk appears in the historical record, it appears as legend, as symbol, as sacred, not as breakfast. That is not an accident. Some anthropologists argue the pattern holds because the same predators humans could theoretically have milked were the same predators humans spent thousands of years worshipping, fearing, and building entire symbolic systems around. You do not domesticate the animal whose image sits above the gate of your temple. You do not build a dairy industry around the creature your culture spent millennia turning into a god. So the real answer was never one thing. It was the energy math making it unaffordable. It was the biomagnification making it toxic. It was the animal itself making it physically impossible without serious injury. It was the taste making the result undesirable even if everything else had somehow worked. And underneath all of it, it was the fact that the same animals humans might have milked were the ones we turned into legends instead of livestock. Every dairy tradition in history runs on the same quiet logic. Energy moves upward through food chains and loses most of itself at every step. We built our relationship with milk around animals that sit at the bottom of that pyramid, close to the sun, close to the grass, close to the source. Predator milk was never on the shelf. The food chain had already put it out of reach before we thought to look.